पैसा हजार कोणती दे?
अच्छा
Sir, you are on mute.
Sir, you are on mute.
Sir, you are on mute.
Good afternoon, all of you.
Good
Good
afternoon.
afternoon.
Good afternoon, sir.
Yeah, one of the student type, we have to start connected bodies. You mean to say we dealt with the kinematics of a rolling body?
Yes, sir. Yes, sir.
Yes, sir.
2 pi r, 8 r,
Yes, sir.
distance traveled by a
Yes,
point.
sir.
Radius of small element Newton.
Connected bodies.
Sir, I wanted to ask something, like
Hmm.
tell something that question 15 the solution is not edited of the part test.
I gave to
Yes,
the
sir.
people setter, I kept them informed, they said they will do it. Right?
Okay, sir.
I will again follow up with them.
Okay, sir. Thank you.
Now, when you are speaking about connected bodies, firstly, let us visualize this using a string. Suppose you are speaking about my marker is the cylinder, pulley. My marker is the cylinder, pulley. There is no slipping between the string and the marker. There is no slipping between the string and the marker. It is opening up. Observe carefully, it is opening up. Right? The mass is going down.
Yes, sir.
It is not a system like this. In Newton's laws, this is what you used to do. The marker used to not turn. The marker used to not turn. But now the marker is turning and there is no slipping between the two. The marker is turning and there is no slipping between the two. How do you want me to visualize lack of slipping? Newton's laws, this was the way the string was moving. Right? Now, have a look. I have placed my finger on the marker. Look at the way it is moving. There is no slipping between my finger and the marker. Are you able to visualize this?
Yes, yes, sir.
Yes, sir.
Yes, sir.
Suppose I take a pulley. Nothing is stored. Pulley is a solid cylinder. Capital M mass, radius R, small m. Capital M mass, radius R, small m. The string is wound on the pulley. There is no slipping between the string and the pulley. No slipping between string and pulley. Right? So the pulley is opening up. Pulley is opening up. The string will go along with. Here I will take the tension to be the same in the string. In principle, you have got translational dynamic equation, rotational dynamic equation, and constraint equation. Firstly, if I take this acceleration to be a translational dynamic equation for this will be mg minus p is m into e. Do you all agree with this?
Yes,
Yes.
sir. Yes, sir.
Then rotational dynamic equation for the pulley. T into R is I into alpha. Capital MR square by 2 into alpha. T into R is giving me clockwise torque. So alpha will be in this direction. P into R. I took the torque about the center of mass because the pulley is hinged at the center. I don't want to invite trouble due to the normal force. So torque about center of mass, P into R is I into alpha. Translational dynamic equation, rotational dynamic equation. Third will be constraints.
Yes, sir.
Acceleration of this point with respect to center of mass is R alpha. Acceleration of this point with respect to center of mass is R alpha. Plus acceleration of center of mass with respect to the ground is 0. So acceleration of this point with respect to ground is R alpha. Right? So acceleration of this point and this should be same. A is equal to R alpha. I repeat the constraints. Please listen. If I take this point to be P, acceleration of the point P with respect to center of mass plus acceleration of the center of the disk with respect to ground is acceleration of the point P with respect to ground. Acceleration of the point P with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of the point P with respect to ground. Acceleration of point P with respect to center of mass is R alpha in the downward direction. Why are you taking downward direction here? Because alpha is in the clockwise. Who told you that alpha is in the clockwise? Your equation told me alpha is in the clockwise. Acceleration of center of mass with respect to the ground is 0. So acceleration of the point P with respect to ground is R alpha. This is point P. This acceleration, two ends of the string should have the same acceleration along the length of the string. So A I will substitute here and alpha value I will substitute in that. Mg minus T is M into R alpha. What is alpha equal to? Alpha is 2P by MR. Find out T. Once I substitute T, finding out A and alpha will not be difficult for you. Translational dynamic equation, rotational dynamic equation, and constraint relations. Take it down, take.
So we have to find T, A, and alpha, right? All the three values.
All three variables. They can ask for any one of them. You have three equations, there will be three variables.
Sir, can you once again show the visualization that you showed with the marker and the middle?
Why you joined late?
Yes, sir, I joined a bit late. I joined when you were explaining the example, so I couldn't understand.
So you deserve a punishment?
Okay, sir, I'll see in the recording. Sorry, sir.
Right.
So which normal force were you talking about?
The pulley is hinged at the center. Pulley is hinged at the center. Pulley is rotating about C.
Okay, sir.
Sir, T is equal to small m capital M G over 2 small m plus capital M.
Okay.
Yes, sir.
Yes, sir.
Right, right. Okay, okay.
Okay, sir.
Noted, so you can run.
2 minutes, sir.
गाड़ी मेरी टू सीटर उसमें लगा
Hello, sir.
Hmm.
Sir, in Vishal sir class also there was some disturbance. So can you please mute everyone?
Now, have a look at this. When I have string on both sides of the pulley, I have string on both sides of the pulley. This is M1 and this is M2. Till now, whenever the pulley was smooth, you used to tell me the tension on both sides is the same. Till when the pulley is smooth. Till when the pulley is smooth. Till when the pulley is smooth, the tension on both sides will be the same. Right? Tension on both sides will be the same. But now there is sufficient friction to prevent slipping. How will it move? See the movement of my finger on the mark. So you need to take the friction into consideration. From here till here, there is friction. Once there is friction, you don't have that friction added to the tension on both sides is not the same. Friction added to the tension on both sides will not be the same. T1 and T2 will be different. Till now, why were you taking the same tension here? Because the pulley was smooth. So the tension is the same all through. Now there is friction along this length. So if there is friction, there will be. If there is friction, there will be a force which will be added to the tension along tangentially. So the tension on both sides will not be the same. Then look at your dynamic equations. Translational dynamic equation, rotational dynamic equation. I will take M2 in the downward direction, M1 in the upward direction. You have made an assumption. You may be wrong. M2 may be in the upward direction. Who knows? But once you make an assumption, stick to it till the end of the problem. Right? M2 into G minus T2 is M2 into A. This is my first equation, translational dynamic equation for this. M2G minus T2 is equal to M2 into A. Come to the second equation. This is M1G. T1 minus M1G is M1A1. This is a consequence of the assumption you made in the start, that this is going upwards, this is going downwards. This is going upwards, this is going downwards. So this equation is M2G minus T2. This equation is T1 minus M1G is equal to mass into acceleration. These are the two translational dynamic equations. And remember, I did not take tension on both sides to be the same simply because the tension here will be adding the friction between the string and the pulley. Friction added up, the tension will not be the same on both sides. Now comes a rotational dynamic equation. You took this going down, this going up. So this should be going up and this should be going down. That means for you, alpha should be in clockwise direction. That means for you, alpha should be in clockwise direction. Right? A1 and A2 may be different, may be same. If we get equal, we will equate it in the last step. We have no problem with it. Now, rotational dynamic equation of the pulley. Concentrate on this. Rotational dynamic equation of the pulley. T1 into R minus, T2 into R minus T1 into R is I into alpha. This will be MR square by 2 into alpha. T2 into R, this is clockwise, minus T1 into R anti-clockwise. T2 into R is clockwise, T1 into R is anti-clockwise. Right? I into alpha, moment of inertia of the pulley, if nothing is stored, is considered to be this. T2 minus T1 is MR by 2 into alpha. All three dynamic equations I am done with. All three dynamic equations I am done with. Right? Translational dynamic equation for this. Translational dynamic equation for M1. Rotational dynamic equation for capital M. Take the correct direction. I have taken A2 downwards, so I want this acceleration downwards. I have taken A1 upwards, so I want this acceleration upwards. Right? Friction has been incorporated into the tensions. Friction you will not take two times. Friction taken into consideration, I have got T2. If I take friction separately, then tension will be the same on both sides. Now, translational, rotational, I'm done with. Now constraints. R alpha is the acceleration of this point. Acceleration of this point with respect to center of mass plus acceleration of center of mass with respect to the ground is acceleration of this point with respect to ground. So R alpha and A2 should be equal. R alpha is equal to A2. Now this is R alpha is equal to A1. Right? R alpha is equal to A1. R alpha is equal to A2. Now from these two equations, I'll get A1 is equal to A2. R alpha is equal to A2 is equal to A1 is my fourth equation, which is the constraint relation. Right? Translational dynamic equations, both of them, rotational dynamic equation and constraint relations. Take it down till here. I'll give you the next problem which you will solve. Somebody is asking, will the tension be different even when the masses are of the same weight? If friction is there, I have no right to assume the same tension. I will take different tensions and solve. If the values turn out to be the same, it is well and good. But it will not turn out to be the same when there is friction. If masses are equal, A1 will be equal to A2. But when friction is there, yes, even in the first problem, there was friction. Only then you can tell me there is no stripping between the string. But in the first problem, you don't have tension on both sides. You have tension only on one side. So that tension involved the friction itself. Yes. This is called a spool. S-P-O-O-L. Please see, there is an inner radius, outer radius. A thread is wound on the inner side of the spool. A thread is wound on the inner side of the spool. Are you people able to see this? This is called a spool, also referred to as bobbin. Also referred to as bobbin. Right? We will solve even this problem which he is demonstrating. But first of all, I want you people to visualize what a spool is. This is a spool. Outer radius, inner radius. It is also referred to as bobbin. It is also referred to as yo-yo, so on and so forth. Can I rub the board? First of all, I will take a disc this way. I will take a disc this way. Observe this. The reverse of this. You have wound this up this way and you are holding this end. Now you are releasing the cylinder. Cylinder is being released. Are you able to see how it is opening up? Are you able to see how it is opening up? You are able to see how it is opening up. This cylinder is going down and there is no slipping between the string and the cylinder. There is no slipping between the string and the cylinder. Right? Generally, the language used is friction is sufficient to prevent slipping. Friction is sufficient to prevent slipping. This is mg. This will be T. Right? Find the linear and angular acceleration of the solid cylinder. Find the linear and angular acceleration of solid cylinder. Translational dynamic equation, rotational dynamic equation, and constraint relations. Think carefully and solve the problem. I'm waiting. Now listen. Translational dynamic equation mg minus p is m into e. A will be the acceleration of center of mass of the cylinder. A will be the acceleration of center of mass of the cylinder. Then comes rotational dynamic equation. Alpha will be clockwise because tension produces clockwise torque. P into R is I into alpha. Mr square by 2 into alpha. P into R is I into alpha. Mr square by 2 into alpha. Right? So 1 R will get cancelled out. T is Mr alpha by 2. Second equation. This is my first translational dynamic equation and rotational dynamic equation. Now the beauty in this problem is the constraint relations. Observe very carefully. Acceleration of this point with respect to center of mass is R alpha. Acceleration of point P with respect to center of mass. You took alpha in the clockwise, so R alpha is upwards. Plus acceleration of center of mass with respect to the ground, A is in downward direction. Should be acceleration of the point P with respect to ground. Acceleration of the point P with respect to center of mass plus acceleration of center of mass with respect to ground will be acceleration of point P with respect to ground, which should be 0. This acceleration should be equal to this end acceleration. Both ends of the string should have the same acceleration. So acceleration of point P with respect to center of mass, R alpha minus A will be 0. Alpha is A by R. Third equation in the constraint relation. Substitute this alpha is A by R and that T here. Mg minus Mr by 2 alpha is A by R is equal to Me. G is equal to A plus A by 2. 3A by 2. A is 2G by 3. Alpha is 2G by 3R. The key catch is the constraint relation here. Acceleration of point P with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of point P with respect to ground. Take the correct sign. Alpha is clockwise, so R alpha will be upwards, A is downwards. Who told you A is downwards? Your equation told me A is downwards. You have made the choice in the start of the problem. Till the end, stick to it. P ka acceleration is 0. Center of mass ka acceleration is not 0. It's opening up. After some time, you will find the pulley here. So this point P is here. P and this will have 0 acceleration. Center of mass will have an acceleration and alpha will be there. This point P will remain here. This is a spool. This is a spool. I have M1 mass here and M2 mass here, hanging on two sides. Spool, I just showed you the video. Spool, I just showed you the video. There will be an inner radius and outer radius. A spool will be more like a dumbbell. Spool will be more like a dumbbell. So when I am seeing from one side, there will be two circles drawn. You are seeing from this side. Right? There will be two circles drawn. This is wound on the inner cylinder. This is wound on the outer cylinder. But remember, spool is one rigid body. One rigid body. Don't tell me outer cylinder is rotating over the inner cylinder. No. Spool is one rigid body. Both together will rotate. Both together will rotate. The tension here I will take as T1. Tension here I will take as T2. Mass of the spool I am taking as 10 kg. Moment of inertia of the spool should be given 10 kg meter square. Moment of inertia of the spool is 10 kg meter square. I don't need to give you the mass of the spool. This is R, this is 2R. Inner radius is R, outer radius is 2R. Spool, do not assume. Spool, do not assume that it is a solid cylinder. Do not assume that spool is a solid cylinder. Spool is a body whose moment of inertia need to be given. They have given us 10 kg meter square. M1 is 10 kg, M2 is 50 kg. R is 1 meter. 2R will be 2 meters. Right? 1 second, there's somebody calling, wait. Now, you are interested to calculate the acceleration of both of them. Acceleration of A1, A2 I will take downwards, A1 I will take upwards. A2 I will take downwards, A1 I will take upwards. Right? Find A1 and A2 is the question. Find A1 and A2. I will wait for you. M2 is connected by a string which is wound on the outer radius. This one. M2 is connected to a string which is wound on the outer radius. M1 is wound on the inner radius. There is no inner cylinder separately and outer cylinder separately. It is one rigid body. Spool is one rigid body. Do not interpret one cylinder and another cylinder separately. Spool is one rigid body. Mass of the spool is not required for you in this problem. Spool is not having linear acceleration. It is hinged at the center. First translational dynamic equation is M2G minus T2 is M2 into A. First translational dynamic equation. M2G minus T2 is M2 into A. Second translational dynamic equation, T1 minus M1G is M1 into A. T1 minus M1G is M1 into A1. I believe nobody has an issue with translational dynamic equations and rotational dynamic equations. T2 into 2R minus T1 into R is equal to I into alpha. R is 1 meter, makes your life much more simple. T2, 2T2 minus T1 is 10 into alpha. All three dynamic equations I am done with. M2 is 50, M2 is 50, M1 is 10, M1 is 10. All three dynamic equations, translational and rotational. Now observe the constraints. Acceleration of this point with respect to center of mass is 2r alpha. Acceleration of this point with respect to center of mass is 2r alpha. Plus acceleration of center of mass with respect to the ground is 0. So acceleration of this point with respect to ground is 2r alpha. I repeat, acceleration of this point with respect to center of mass 2r alpha. Plus acceleration of center of mass with respect to the ground is 0. So acceleration of this point with respect to ground 2r alpha, which should be equal to A2. Similarly, acceleration of this point with respect to center of mass is R alpha. That means you have taken alpha in the clockwise. Why? Because of your dynamic equation. You took T2 into 2R minus T1 into R. T2 into 2R you have taken positive. So this is clockwise alpha. So 2R alpha will be downwards with respect to center of mass. Plus acceleration of center of mass with respect to ground is 0. Same here, R alpha with respect to center of mass. Plus acceleration of center of mass with respect to ground is 0. So R alpha should be equal to A1. So technically A2 is 2 times A1. Simplify the three equations, you get A. Alpha is A1 by R. Alpha is A1 by R. A2 is 2 times A1. Three equations, three variables, T1, T2 and A1. Eliminate T1 and T2, you get A1. Once I get A1, A2 is 2 times A1. Somebody is asking, why will hurry? Why won't A1 have a negative sign? Why should A1 have a negative sign and which equation you want? I took A1 upwards. T1 minus M1G. Why will I put a negative sign? Use some common sense. Second, here if you want A1 is equal to minus R1, both are in the same direction. Why should I put a negative sign? I don't understand. Hurry, speak. Next problem you people will try on your own. Please make this fast. I'm waiting for you. People who have done it, please wait. Have patience. So finally your equations are 50G minus T2 is 50 into 2A1. T1 minus 10G is 10 into A1. 2T2 minus T1 is 10 into A1 by R. R is 1. Now this simplification should not be difficult for you. Multiply this equation with 2 and add all the three, your job is done. Multiply this equation with 2 and add all the three equations, you get A1. First equation multiply with 2 and add all the three equations. This is light and smooth. This is a solid cylinder. Solid cylinder, right? Friction is sufficient to prevent slipping between the string and the cylinder and between the cylinder and the tape. Friction is sufficient to prevent slipping between string and cylinder and between cylinder and ground or tape. There is no slipping here, there is no slipping here. This pulley is light and smooth. Capital M is 10 times smaller. Capital R is 1 meter. Find acceleration of both masses and friction F. I'll take friction F in the forward direction. He is asking for acceleration of both the masses and the value of friction F. He is asking for acceleration of both the masses and the value of F. Friction between the cylinder and the ground. BET dot is between. This is the abbreviation for between, though not official. Friction is sufficient to prevent slipping between string and the cylinder and between cylinder and the ground. So the string is wound on this cylinder. When you draw the free body diagram, you have tension T here and T here. You have friction F. This will have an acceleration of small a. This will have an acceleration of capital A. Direction of friction is not given in the question. I gave you people so that there is uniformity between us. You can assume in the backward direction and solve. Body is rolling. If my assumption is wrong, you'll get a negative sign for friction. We have no problem with it. Mg minus T is M into E. First translational dynamic equation. Second translational dynamic equation is T plus F is capital M into capital E. Capital M is 10 times small m. Translational dynamic equations of both the bodies. Capital A will be the acceleration of center of mass of the cylinder. Rotational dynamic equation for this, P into R minus F into R is I into alpha. Capital MR square by 2 into alpha. I is capital MR square by 2 into alpha. Right? Capital M is 10 times small. All three dynamic equations I'm done with. You can as well take the torque about point of contact. I have no problem with that because the body is rolling. Point of contact is not accelerating in this direction. Right? So you can take the torque even about point of contact, but if you do that, moment of inertia will be mr square by 2 plus mr. We are perfectly okay with it. T into R is clockwise, F into R is anti-clockwise. So T into R minus F into R. Now constraint relations. The cylinder has an acceleration of capital A this way and alpha this way. Alpha, why are you taking clockwise? You have taken it clockwise. A, why are you taking it forward? You have taken it forward. This is R alpha minus R alpha with respect to center of mass plus acceleration of center of mass with respect to the ground is acceleration of this point with respect to ground, which should be 0. A is equal to R alpha is my fourth equation. Acceleration of this point will be R alpha plus A. With respect to center of mass is R alpha. So R alpha plus A is the acceleration of the topmost point, which should be equal to small. This will be R alpha plus A, which should be equal to small. From here I will get 2 times capital A small a, something which I actually knew. When a body is rolling, topmost point will have 2 times the acceleration of center of mass. When a body is rolling, topmost point will have 2 times the acceleration of center of mass, which I knew, but I officially showed it to you. So AR alpha, if I substitute here, small a is 2 times capital. Small a is 2 times capital A. Alpha is A by R. Alpha is A by R. 3 equations and 3 variables. T is one variable, F is one variable, A is one variable, capital. Eliminate T and F, you should be getting capital A. Should not be difficult for you. Once you get capital A and T, you can calculate friction here. Neither all 3 variables you can calculate. Tension is the only thing they didn't ask. Somebody wants to take torque as F into R minus T into R. That means you are assuming alpha is an anti-clockwise. So for you, here R alpha will be towards the left, here R alpha will be towards the right. Make the corresponding change. If you want to take FR minus TR, that means you are assuming alpha is an anti-clockwise. Alpha is an anti-clockwise means R alpha will be forwards here and backwards. Accordingly, make changes for your constraint. Before people drop out homework, I need to discuss one more problem. Please wait. Homework. HCV exercise problems 1 to 44. Except 25th CBIT. In 25th CBIT, they ask for angular momentum, which we are yet to teach. So, except for 25th CBIT, this is small r, this is capital R, this is capital M, this is a spool. This is a spool. Mass M, moment of inertia is I naught about its center of mass. Mass M, moment of inertia is I naught about its center of mass. Right? Write down the dynamic equations and constraint relations. Listen, there is no slipping between the string and the spool. He did not say anything about this surface. No slipping between string and spool. On the inclined plane के बारे में nothing is told. Temporarily assume this to be smooth. Smooth inclined plane. Smooth inclined plane. Just write the dynamic equations for me and the constraint relations. I don't want the simplification. Translational dynamic equation would be mg sine theta minus t is capital M into E. This will be mg sine theta minus t. Rotational dynamic equation will be T into R is I naught into R. Normal force is passing through the center of mass. There is no friction. Only tension produces torque. Now try the constraint relation. No, constraint relations will be like this. You have taken T into R means alpha is clockwise. This will be R alpha, this will be. Who gave you the directions? You gave me the direction. You took mg sine theta minus t. That means A is downwards. You took t into small r. That means alpha is clockwise. Now acceleration of this point is r alpha minus A should be 0. Because this point is 0 acceleration. 3 equations and 3 variables. Now most importantly, listen to this point. Next class, I'll connect this to a pulley and it will be hanging here. Then listen, I will first decide if I want this acceleration to be in this direction or downwards. If I want this acceleration to be in this direction, I'll take r alpha minus A. If I want that acceleration to be downwards, it will be A minus R alpha. If I want it to be downwards, it will be A minus R alpha. If not, it is R alpha minus A, which we will deal with in detail in the next class, laying the foundation for it. When is our next lecture? When is our next lecture? Thursday. Okay. Somebody raised your hand. One second.
Yes, sir. By when do we have to submit the homework?
You don't need to submit the homework to anyone. Do it, make it fast. I'll take up the doubts in the next talk lecture.
All right. Thank you, sir.
Jay Shankar.
Yes, sir. Sir, my doubt is how did you get the constraint relation? Can you explain it once again?
उसमें डाउट बोलो यार पूरा क्लास यही सिखाया मैंने अदर देन दैट वी डॉट नथिंग एटलीस्ट फॉर द पास्ट
सर मुझे ये समझ नहीं आया कि आपने आउटर रिंग के लिए कंस्ट्रेंट अप्लाई क्यों नहीं किया इनर रिंग के लिए एक बार बता दीजिए ना
string is wound to which inner or outer string is wound to the inner one or outer one hey, this guy is spammer here nonsense fine see you people in the next class good day